nasze oczywiście, w sensie wasze wszystkim. Debugger do Commodore 64. Prelekcja będzie po angielsku, bo on zna ten obcy język, to sobie poradzi. Więc proszę? Czy będą napisy? Slajerek, będziesz miał napisy? Nie. No, będziesz musiał się starać. Także zapraszamy na pierwszą prelekcję Slajerek, Samar i C64 Debugger.
I'm not ready, of course. Just looking for my discs, Commodore 64 discs. I think it's here. And do I have games? Games. And I have games. And I have this game. Good. So, I'm not very well prepared today, unfortunately, because we had too much party yesterday, but I hope I will give you some glimpse into new features of the Commodore 64 Debugger, which is a tool for debugging the Commodore 64. It is based on the Vice 3.1, the emulation engine, and thanks for this to the Vice development team. And they did a very good job on this emulator, but I added some features which are helping us in debugging the demos. Like maybe you have seen today there are like these guys, their guys working on last fixes and demo crashes, and I hope we'll see today very good demos and productions. Anyway, so let me just show you a bit what we have here. I mean, I would like to start with some history. So first of all, the Commodore 64 Debugger version 0.64 56.6 will be released today. I mean, in principle it's ready, and I have the release candidates builds. But as I said yesterday, there was a very good party here, and we need I think I will release it in 1 hour or something like that, just after this lecture. What we have in the new version, we'll have some bug fixes, of course, and quite importantly, we'll have the REUS settings, so the memory, additional memory up to 16 megabytes. So I added this, of course, what's more important. So you have this in Vice, of course. So what I added is a live view of the REU registers in this registers view. So you can edit them online, real time, and also view them, of course. So for debugging, it's very good. So that was missing in debugger. Now it's gonna be here. What I added also, which is helping us a lot in making our demo, is some nice features which were like suggested by guys at X 2018 during my talk there. It was nice discussion afterwards, and it was really, really constructive. So I added a few things which we were suggested there. First of all, timestamp, frame number, and cycle number counters, and they are shown in this, of course, our view for all the registers also, and you can zero by them, shift backspace, and I will just show this in a second. Just I would like to quickly go through this, so you know if you know already debuggers, you know what you can expect. And I added a bit more for the profile log. So my focus now is this profiler to be able. Oh, hello, Digger. So I just entered the guys who suggested me so Brush Elysium and Digger. Hello, guys. Just entered, and there are like they gave me this idea that we have this Champ 6502 profiler in GitHub, it's open source, which is it's able to parse some profile data and do nice profiles and like diagrams and etc. I will show this also. Anyway, I added this, and it's my kind of task now to extend this. And I added also some more debugger API functionalities. I'm also gonna show how this works, the debugger API. Debugger API in principle is very, very early stage, and it doesn't have, in principle it's based on kind of plugins you can plug, and API so you can do some nice stuff. But it is really, really early draft, so you have to mess with sources to do this. So a bit of history. So all started with this guy, in principle. It's Ramos. Unfortunately, he passed away. Anyway, so he asked me in 2003. I mean, it was like off the scene, and I forgot about Commodore 64. And in 2003, he found me and asked if I have some my music disc I did in some seed tunes, just to, you know, send him, and he will make this. And it kind of started then, because I sent the disc, then he sent me the seed tunes. I was like, wow, back in 90s, right? I was like, it clicked again. So in 2007, I think he suggested it once again, and I was like, he was calling me all the time and trying, you know, convince to come back, and then unfortunately, we had this idea to make a demo which will work on Atari and Commodore 64 at the same time, so two platforms displaying. But I realized we don't have tools, and I mean, it was like 5 days earlier we spoke about this, and then he passed away. It was really, you know, disaster for me. Then he asked me to enter the Samar, and I've seen this. Maybe you know, this is a Forever Lost picture, beautiful picture by Isildur, and I was like, oh my God, these are like best artists I've ever worked with. So I decided, okay, I will come back. So my decision then was like, let's do it. So okay, let's do a demo. Why not? And then I really realized that on my Mac OS, I don't have tools. I mean, like, I had Vice, of course. At that time, I think it was like 2.4 version. And I started kind of thinking that maybe it's a good idea to work on the demo, like do a proof of concept in C. It was easier for me for working in C. And then just port it to assembly, yeah? And I started mocking up some effects in C, which I had my kind of own emulation screen for VIC. But then I realized why I'm doing this. I mean, come on, we have emulators. I can just, you know, use emulator, and you just go there, and if there is one emulator who can, you know, work with my tool, my in C, so I doesn't have to write all this stuff like painting pixels and etc. And there was Frodo, and my first emulator which I added was Frodo. But the funny thing, probably it wouldn't be like that if I mean, the problem was that it wasn't working for me. So I started debugging the C code of Frodo and my engine. Why I don't see anything on the screen? Why it's black screen? And I just like started to adding some things. So I added the PC, the program counter, and I just displayed on the screen. I saw, okay, so program counter is correct. So it seems that the emulator is kind of working, but it was stopped, was not displaying anything. Then I thought, okay, maybe I will show what's there, because maybe I thought it's maybe there is no RAM. I mean, maybe the ROM is not loaded, it's 0, so it's just, you know, jumped. And so I didn't have a memory display handy, but I had my disassembler, which I wrote, I don't know, 5 years earlier. So I put the disassembly code. And then it didn't work, but I've seen that disassembly kind of is working, so it's displaying correct value, so I think, okay, ROM is loaded. And there was a very funny moment when I realized that the emulation speed was set to 0 in Frodo. So I said, okay. And then I've seen this, so the ROM was loaded, and then I've seen this. And it was like, wow, what's this? Oh, okay. On the left, I see the live code, and on the right, I saw the perfectly working emulator, and I was like, wow, this is nice. Let's, you know, extend it. And then I added memory map. Just I thought this is gonna help me in making my demo effect. So then we had this Samar meeting when I met school, DKT, yeah, Don Quixote, and we had this brainstorm meeting where the guys were very happy about the debugger. It was working at Frodo, and they said, no, you have to port this to Vice. And then I released this at Stary Piernik 2000, oh my god, I don't remember when. I think 3 years ago around. And yeah, that was a kind of blast. I mean, it was a very nice tool, and people were very happy. And yeah, I started working on this. I created the fan page, like Facebook fan page. And as you can see, we just have some nice ideas posted here and discussions. And in principle, very funny thing is that I then added the Atari 65. I kind of wanted to. People constantly ask me why I'm, you know, spending time on Atari 65 and supporting enemies. Yeah. No, and actually the fact is that my first computer I have ever worked with was Atari 65. So then my parents bought me the Commodore 64, which I wasn't happy because all the colleagues had Atari 65. And I had like Commodore 64, which doesn't have, you know, working BASIC. I had, I mean, good working BASIC for, you know, sound functions and stuff. And so I started, playing with assembly. And I think that was a very good choice, actually. I like the Atari 65, but Commodore 64, I think it's a bit, you know, I'm not gonna say it because it's live. Anyway, so I always wanted to see the guts of Atari 65. So there is a very kind of early version of Atari 65 debugger where you can also play with this. Okay, so this is on the SourceForge. Of course, it's open source, and some people already, you know, we are like contributed. So. I wanted to say something. Anyway, I forgot, of course. Anyway, so just let me go to the to Commodore 64 debugger. Not sure if we have a sound a bit. Boris, where are you? A bit, not too much. Thank you. So. I'm gonna, you know, go through. This is actually a very bad image. It's a Petsky art. So I'm going to show you all the kind of features in this debugger. So first of all, this is my first view I've ever created, and it shows on the right the emulation, of course, and this is the processor status, and we see here all the, you know, values, standard values, the current cycle counter, VIC cycle counter, the raster Y position, the raster X position, and this cartridge status. Here we have some nice, of course, this assembly code. It's quite important to understand how to use it. So. In principle, I'm planning to add, of course, like toolbars and icons and stuff, but it's not highest priority for me now. I just would like to finish all the functionalities I have planned, like since the beginning, plus some additions like profiler, which are important for kind of the guys who are, let's say, working on this and asking for features like profilers and stuff. So I think it's a bit, you know, steep, you know, learning curve, but if you learn the keyboard shortcuts, it's like easy, I think. Even we had this discussion with Golara yesterday that he at the beginning he didn't like the debugger because of this, you know, multiple keyboard shortcuts, but he told me yesterday that it's actually a very good idea because you don't have this icons everywhere, and it's just you have to memorize the sum of shortcuts, and you can use it. So anyway, of course you can scroll it. What you see here, in the white color, it is the marked some the code which was executed. and gray is code which wasn't executed yet. You can of course delete these markers, but I would like to go to settings and UI a bit. So for example, you can change the colors here, like menu theme, and I think there was some disassembly execute color. We can put yellow, for example. Some asked me it's better, so let's do this. Okay, so now you can change the colors. But anyway, I'll go back to white, which is something which I. Anyway, so the disassembly works in a way that it's marking the white, with white color the place where it was execution. As you can see, it's jumping here, but importantly, the disassembler works in a way that he will try to always put your disassembly not moving in the moment where you are with this bar, right? So if you scroll it, you can scroll by 1 byte. So maybe let me change this to this view, where you can see a bit more the hex codes in the memory and the number of cycles the instruction should take. This is not taking account the the page changing, so it's maybe sometimes you need to add 1. Anyway, you can move this bar by byte by so what is this? The bracket. So you can see if I move this 1 byte, the number here changes, showing that I'm now on the C101 memory place, and as you can see, it tried to disassembly in a way that it's not moving, so it's stopped. Here was the execution, but you are here displaying and it wasn't executed, this particular place, right? So I think you can delete this with control backspace. Yeah. So if you would like to go by step, it will mark them again white. Okay. And so as for the stepping, right? So it's a bit. I think it's like Visual Studio 2008 or something like that, or I don't. Maybe it was even older. Some tool, Borland C++ or something like that. It's F10 is for stepping, 1 step. F11 is for running. If you move this, you see that this is not showing the current, program counter here. So you can change the modes using space. Okay, so if you are somewhere here, pause, and would like to jump to the place where there is a processor, you just press space. Okay. You can do a bit here more. I mean, like for example, using arrows, like keyboard arrows, you can move to the, deeper to the procedures. Using the left arrow, you come back, right? Okay, so you can just quickly scan what's there. Okay, I'm here. Let's go here, and let's go here, and then go back, right? And if there is, excuse me, if there is the memory, like reading memory, etc., so you can just using the left arrow, you see that I moved here with this memory dump to this place. Okay, start it. So about colors, here you have the memory map, which is showing in real time the whole memory map of the Commodore 64, and you can zoom in, move around, of course. If you click here, you see that I moved with this cursor also. If you double click, the disassembly is being moved, and with so first of all, these colors, what they mean. This is the current value of memory. Let me pause this and just delete the markers for a second. So this is our Commodore 64 memory, which is mapped into RGB, meaning that first 1/3 of 255 is R, then G, then B, and you can change this in, if you go here, there is a memory, and you can change the memory map values to gray, so they are like from 0 to 0 is black and 255 is white, and then you can maybe also just don't show them. Yeah? This here is a marker which is a bit more visible. It's showing the current processor program counter. The kind of white colors are meaning that the code was executed. So you see here it's blinking because it's executing code. Blue means it's reading, and red means it's writing, and purple, which means reading and writing, because it's two events. So you see here, this value was read and then written. All right. So what's here also? For example, if you would like to know, so let me maybe start some game. And we have the cybernoid and command. Okay, let's do commando. So what I did, I inserted. Stop. I inserted the game, and just if we are here, so I inserted the disk, so it is here. I can just click enter. So F7. When you click F7 on some place here, you can. Put this a bit lower. In principle, you can click somewhere here on the controls, F7, and you are in a directory. So you can just select the file and enter. But of course was on the running code. Anyway, so the other thing is which is quite important. If you go to emulation, there are like these settings which are important, because first is always jump to the loaded address. Means if you drag and drop PRG or drag and drop the D64 disk image, if you set this load first PRG from D64, it will try to start the first title in the disk image. And this will change the way it works. So normally, if it is set to no, means that I will try to parse if it's the program starts at the 0801, meaning that it's the basic program. If it's basic, I will try to run it. Yeah. So if it's 0801, I will just put basic values in 0 page and etc. and just start it. Yeah. But if I put this to yes, I will just jump there. So don't care about if there is basic or whatever. If it's like address is 2000 hex, so I will jump there. It's important that if the PRG, if it's set to no, and if there is no PRG, sorry, there are no basic 08, the PRG starts not with 0801, I will do nothing. So meaning, for example, if you're working on a game and you have assets, you can put them in PRG and just drag and drop on or press enter in like Total Commander or your file explorer, and it will be loaded instantly into running code. Shall we reset the Commodore 64 before PRG load? So you see that was set to no. That's why my commando crashed, because I just put on the running commando another commando. I tried to start. There was some interrupt working, which crashed. Yeah, but if I set this to soft or hard, I will just whenever I try to start the PRG, I will just reset the debugger and wait 1300 milliseconds. So I advise you also to put this value to yes. This is fast boot kernel patch, which is just skipping the startup. You see here on the startup, the Commodore was testing memory, the kernel. Okay, but of course, if you are working on some advanced stuff, you don't need this. So just quick reset, right? All right, so let me put again this commando thing. Righty. So it started. Joystick. So with command shortcuts. So regarding the keyboard shortcuts, so there is a keyboard, you know, this sheet where all the shortcuts you can print and put. Some I think at least 2 exist. I hope we will be able to excuse me to extend this. I'm not working too much on the documentation. I'm sorry, I always forget about this. Anyway, so command or control Y is changing the joystick on off. If you are about, of course, shortcuts, keyboard shortcuts, you always, of course, can set your own mapping of the keyboard and set your keyboard shortcuts as you wish, yeah, and export them and import. I know that Isildur, for example, is having his own crazy, maybe not crazy, maybe very good keyboard shortcuts. So, and of course they are saved. So, what we have here, we are having running code. So you see that the music player is working. So if you excuse me, if I go here, you will see that we have the VIC details here on the right. This is a small version of this. If you click here with the mouse, you see that was changed to showing the real values of registers in real time, and you can go here and edit, and it's reflected immediately. If we go to the next, here we have on the left we have the Commodore 64, on the right we have the disk. We'll see some demo in a minute, so we'll see how this is working together. This view is for all the most important registers. The VIC on the left here, SID, and you can, in principle, there was some bug recently. Recently there was some bug. I hope I fixed this, so we can, in principle, just edit it. So if you would like to play with, you know, SID music using pure registers, you can do that. We have this control ports, and you can see the values, of course. This is, of course, the VIA, so it's on the disk drivelet, and I added this recently. This is showing the frame number, time, current time running, and cycle, which you can reset with Shift backspace. Oh, you see, it's resetting the value, and more importantly, if I drag and drop here the commando, it was also reset automatically. So if you are working on a demo, you can say to your colleague that, listen, on the frame 600 something there is a problem, and if he starts the demo it will be the same. So in the same frame it will be synced together, because it's starting just from this moment where I do jump to the first instruction. Emulation speed, some frames per second. This is a very big memory map. This is a bit showing the disk disassembly and the control ports. This is, of course, classic. Oh, I see. You see, I'm on the older version, not the current. Anyway, you can use help. It's not connected to device monitor yet, but I'm kind of working on it, and I have a proof of concept, but there is something is not working properly. So it's just standard action replay kind of monitor. F9 is just this menu where you have settings, and another views start with Command and Shift F1. So this is showing the current position of the raster. If you, for example, go here and press Command Control E, you can see the position of the raster. So if you run it, you can see it. Oh, maybe before I go further, let's play this game a bit. Joystick is on, keyboard arrows and Alt, and I'm here playing game. Yeah. All right. So I would like to show this. This is a view, I call this this is called Vic display, I think. I forgot. Vic display. This is showing the state of the Vic. As you can see, if I move this here, I can click and block it, so it's stopped here. You can see this is a bit reddish, so it's red. Meaning that it's not the current status of the Vic, but what it was in this particular frame. So if I pause it and move it around, you see that this changes here, showing where was the raster, where was the processor when I was here in this raster, and what was the state of the Vic. Okay, oh, okay. So what I would like to do, oh, not like this, is here. So here you have a small kind of button, which is not a button, label, showing what I'm looking for. This is raster, showing that where I was when the raster was here, but I can change this to bitmap, meaning which code put pixel in this position. Screen means which code put the char, and color means the 800, right? And charset. So we are looking, of course, for the screen and this particular value, which is number of lives. So you can see that was the 04FF was taken and some added number and was here. So this is the number of lives, and here at 04FF probably is the value of lives, which is 4, which is correct, I think. So let's die. Should change to 5. No, sorry, it's grenades. Ah, come on. Not this. This one. This is the 0500. So this 0500. Sorry, it was the number of the grenades. So here is the number of lives, right? I have one left. Stop. 05. Control. Click on this value. Will move me to the place where this value was written. So this is deck 0500, meaning, okay, when you died, remove one life. I will put 3 knobs, and I have the unlimited lives. Okay, it works. So, excuse me. So in principle, it's quite powerful tool here, where you can just find for things like who wrote the pixel on the screen, I mean where it was written, etc., etc. What was running, yeah, at this particular moment, and stuff like that. This view here is for the source code. I will show this a bit later. So Command Shift F5 was this, and we have here, excuse me, I need to just put this. It's allergy. I'm sorry. Today is May, meaning that I'm quite, for this pollen thing, I'm crazy. My voice is crazy. But this works. This tool is nice. Whew. Anyway, so this is a Vic editor. In principle, which is first of all a thing which I'm going to expand later, meaning that probably all the views which we've seen there previously will be put into this also. So you will be able to, first of all, I have dialogues here, so you can move this around. See, for example, the sprites. Zoom in. and see values. And you can paint also. So you can select here the char set, like here, this one, and you can, color. You can play a bit. For example, in Jana Sisters, you can play, put really the bricks, for example, and Jana is jumping on them. Vic Editor will be covered by Isildur today. Not sure if it's gonna be in English, maybe in Polish, but you can always do, Google Translate. Anyway, toolbar. You can go to settings. Clear the screen. And kind of more importantly, you have this open file, and you can import the file. Sorry. And you can create a new file. You can create just a bitmap multi. It will just, create a clean image. As you can see, it created a clean, simple jump here, which is just stopped. And you can, start painting your beautiful whatever. and here is also the import functionality. So you can, import a PNG file. For example, Isildur is working in a way that he's painting most of his, pictures in Photoshop, and at the end he's importing this Photoshop file to this debugger, and to just polish the final touch of the image. You have here some layers, like unrestricted layer, meaning that it's you can use no limits with colors. Sprites, you can paint on sprites. The display, this is the Vic display, and Commodore screen. But anyway, Vic Editor will be covered by Isildur. So what I would like to show you more is some other nice features or recent features. First of all, you can go to emulation, and we have this profiler file I told you about, but let's firstly do the, I wanted to go to memory, of course, and map the Commodore 64 memory to a file. And what it does, unfortunately not on Windows fully, but on Linux and Mac OS, what it does is mapping the real emulator memory 64 kilobytes to a file, meaning that the file is a mem mapped. On Linux and Mac OS, you can read and write, and on Windows you can only read. I'm not sure how to make this work on Windows yet. Anyway, so if I put here, excuse me, if you put here select file where I would like to have it on desktop, I need to restart the debugger just to perform the mapping, and now I should have, I hope, I should have, so you have here a debugger. I'm gonna put it on always on top, so you can go here, always on top, yes, and it's gonna be always here. Ta-da. Yeah, it is. So here you have the Commodore 64 memory. Sorry, I normally have time to clean my desktop. As you can see, if I go here and let's say raw, I think it was like that, this hex, and edit, let me go to the screen RAM. It's somewhere here. I will put, I don't know, 3139 and save. As you can see, maybe you've seen, maybe not, here is 2019. So you see that you can even write your proof of concept code in Python, writing directly to memory, and do painting pixels, whatever, and see immediate result. Because if, of course, this is screen, but if you go work with bitmap, it's also working. Okay, so other thing is the profiler, which is, as I said, it's a bit early stage, but it's quite, you can work on it. So let me set profiler file, desktop. It will, as you can see here, the standard extension is PD, like profiler debug, something like that. Save, and now I have set the profiler file, and I can start profiling. You see there is this shortcut, Command Shift I. Let's do this. Yeah. So in principle, I just started the profiler and stopped. So it created a log. Let me put this box to not always on top. It created a profile log, which looks looks like this, and it's showing CPU, the cycle number, some previous. Sorry, this is the program counter, the registers. I don't remember. It's written in the README. Sorry, guys. Anyway, what's important? I can. We have a tool. This the Champ, which is the Champ profiler. Was written not by me, but I added some changes to it to work with my debugger, and it works like this. So I set the Champ with the profile file, and it's working and creating a report, which is standard HTML report. You can see here and run the, and it's presenting something like this. So what this is a very simple version of it, and I'm sure it can be extended, and I hope I will be able to do this profiling even in live, like real time. But see, it took some time to calculate, so maybe it's not that easy. Anyway, what we see here is that we started with FFAA, and you see that most of time was spent in this procedure, EA87, which is, I think, basic prompts, waiting for keys and etc. And you see there were like number of calls, 94 calls here, 90 calls there, and etc. etc. So kind of, you know, basic profiling info is here. Yeah, it's good for, let's say, demos, and when you are looking for the places where you can you know, find some cycles. Sorry, something happened, something wrong happened with this. Let me, I'm zoomed in, sorry. So profiler, and what's also important is that just in this version, which is not supported by this Champ profiler yet, I added the possibility to also do VIC profiling, which will add to the profile log text file will add also events, not only CPU but also VIC, and in VIC you have possibility to see a bit more, you know, like DMA of sprites DMA, bad lines, etc. etc. Good. What's the time? Actually, I'm not just. It's around 1 hour, so I have around 1 hour here. So let me start some demo. You can see. Let's see some guts. Okay. So which demo should I start? I'm not prepared here, so I have some folder with demos. Crestology I have. Okay, why not? Let me put Edge of Disgrace. Okay, it's a bit more technical, so let's have a look at this view. So first of all, what I'm going to change here is the behavior of this, because if I would put the second disk, it would restart the Commodore and start the PRG there. So I'm just changing this to no, to put the second disk. Bam, and I insert it, and we see the demo working. as I said, on the left you see the memory map, so the map of Commodore 64, what it's doing, and on the right you can see the disk drive, what it's doing. Well, let's wait a bit for the loading of the part. By the way, of course you can go warp with Command P or Control P, which is speeding up this a bit. So you can see this is loader working on the right, and on the left we have the effects. Music up a bit, please. All right, so if I pause this, of course I'm in pause state, so I can look what's here, what was written, what was read, go here and play around and see the codes. Of course, I'll try to understand how it was produced. If I go here, you see that I'm scanning this to see where are the sprites and etc. Let's wait a bit. So, in principle, as you can see, it's quite important to understand this view, that it's showing this is displaying the screen how it would be, rendered by Vic if there was no raster changes. So it's like in this place here it would render like this, in this here like this, like this, like this, like this, and you see here is this checkerboard probably. Interesting is that it's I don't know how this effect was done, but interesting is that it's right here. So I think they are using some FLD whatever tricks. The HCL is HCL we say in Polish. It's using some tricks here. Here you see the sprites, and you see here also that they are like put on the top of the screen. So I think some FLD is here, involved. But if you go here, see that the Vic editor also tries to mimic to put them here. It's not working correctly, of course, because it's on the top. This here, that here. Okay, so source code. This is also one feature, it's for programming demos. I wanted to show one demo. I forgot about this. Do you know the name of demo with this lady on the sea, which has open borders image? What was the name of demo? So sorry, I forgot the name. I'm not prepared. Doesn't matter. So anyway, last thing I wanted to show you is a possibility to how I do this. How to say in my environment. So this is README. I have 10% of my battery. Could you please give me the charger? No. Oh, perfect. Yeah, perfect. I have, guys. I'm with friends. Okay, so okay, let's. This is an effect I wrote. This is a simple effect I wrote for rediscover demo. Sorry if it's not working, for example, for some reason, because it was very, very long time ago when I was working on it. So in principle, what this does is opening borders and displaying some sprites. So I have here the Sublime. If I run it, I start the debugger. Okay, see? So it was quite quick. Let me put this always on top. Sorry. But what I wanted to show you is a possibility to, how to say, link to tools. So Mads Nielsen was kind enough to work with me on the API. We exchanged some data within the debug symbols from the kick assembler. And when I started this, you can see that it started debugger. So I can, of course, go here, make some changes, like this, compile, and it will be again reflected here. But what's more important, you can see here, is the mapping of the source code. So it's not very beautiful yet, but it works. And as I said, I'm going to add some debugger API for external tools like VS Code to be able to parse this and be able to show the to do stepping from external editor. And what's important to map the code here, what I have in the disassembly, with my source code, right? So this is, where do I have this say? Okay, here's this. If I add an op, you see here is added an op. If I scroll, I see my source code, right? And if I have like some here, if I, for example, I go for a macro, it will show you, of course, the macro. So the place in the source code where this particular code in memory was, created by the assembler. Some pseudo commands, and here, for example, knobs, like opening borders. And so, okay, so if we go here, you see that this effect works in a way so that, of course, I'm like doing the multiplexer classical on the borders. Opening borders, do D016, playing tricks with some the size of the screen. Anyway, what I did here is, I of course scan this so I can see what's going on here. By the way, it's quite important to understand this, that you can change the border. So this is a full border that was previously wasn't full. It's a bit some kind of only the visible, but this is a full PAL or NTSC the frame. Of course, so some code is also run here. You can see the bed lines or fetch lines. Border is this. Grid, show sprites or not. Show frames of sprites or not. You can jump here and do the breakpoint, and we'll just create a breakpoint. As you see, immediately it stopped. It stopped because the raster came to this moment, to this place, and it's creating the raster breakpoints. Okay, it's running. Here you can change force the modes, like text mode, bitmap, high res, multi, and standard or extended, and select the place where is the screen. Force. By the way, if you would like to see this real time reflected, so you can double click. Yeah, so it's like red means it's sorry. Here red means that it's forced. I'm forcing displaying screen how it would look like if I here double click. So once again click here, and you have it green, meaning it's reflected from the VIC. The same with charset and bitmap. So, and if I, let's say, click here, so you see it's in the blocked position. It's quite also important to understand this kind of UX. It's if I'm in the blocked stage, it's important here it's red, and it's kind of small red, right? Or not, meaning that all the views here show the this data coming from this particular moment in time. So, but I think not memory yet. But all the VIC status and all the other registers are just from this particular moment when I'm here clicked, and I can move with my arrow keys up, down, this arrow a bit. With shift, you can jump a bit further, and for example, so I'm moving just now here one cycle. I think we'll be opening borders here. You can see that in this particular place here. Let me remove the sprites for a while. So here I'm opening borders, knobs, borders, knobs, borders, sprites, multiplexer, knobs, borders. Oh, bad line here, you know, it's this trick here to make a bad working this on the bad line. You see here, this is on red, meaning that I'm on this particular bad is a, you know, fetch line, right? Bad line. How do you say it? So actually, I constantly hear this discussion. Some people say bad line is very, you know, bad wording, bad name. Maybe I should change this to fetch line. Anyway, I put bad line because it fits in the button here. So anyway, so this is a tool, nice tool to this particular screen. Is very good to understand what is going on with your code, and of course to debug and understand where is the problem, and of course to, you know, watch demos and you know, just enjoy, yeah, enjoy watching demos, and in a bit different way. Let me put this demo. Sorry. So what we have in this debugger, I mean, about tools which I'm not gonna show you is, for example, we have a kind of scripting language which allows you to do some automated tests. It's also a bit basic. It's based on, I think, or kind of XML. But what you can do is automatically prepare such script and pass it to the debugger, and what you can do put in this script is, for example, load disk, run PRG, wait for frame number 300, move joystick left or move joystick right, put, you know, keyboard events, or dump memory, do some stuff, put another, do fade in, do fade out, and etc. Sorry. Okay, so I advise to read the README. I mean, it's a bit, as I said, it's a bit steep learning curve, but it's if you go through the README file, you can find it everything there. Especially command line options, which I'm not gonna show here, but maybe a bit, but just from the README file. Command line, where you are? Oh, there was. Okay, so command line options. You can start the debugger with some predefined layout, the breakpoint to breakpoints file, symbols file, which are the kind of symbols, debug symbols, for example, from the kick assembler. Watches, wait, PRG, blah blah blah. Do auto jumps, stuff like that. But more important, the most important is this. The pass command line allows you to not start the new instance of the debugger, but just pass these command lines to the existing working, running instance. So meaning, for example, you can do such thing I showed you here. That I showed you here, that if I would like to start it, I just press F5, and it was like this. So it ran in the behind the scenes. Started the C64 debugger, which passed the you know, all the parameters to this particular here working instance. Okay, so I think in principle I'm just finished my talk. Not sure if you have some questions, discussion. I would just gonna put some demo maybe, and we can enjoy this a bit together. Anyway, questions, suggestions. All right, no questions. Everybody knows the debugger, that means. Let be this a new unboxed or Star Wars? Star Wars 1. Okay, so thank you very much. Let's watch the demo. Oops, no, come on. No, there is very important thing I forgot about. Of course, I wanted to show you the Debugger API. I am sorry for this. It's good to have this opened. So, of course, the demo I will put in a while. So once again, coming back to the very short presentation of this Debugger API, which is very brand new, believe me. So it's like, I don't know, I added this recently. That's why I forgot, because it wasn't before in the other lecture I did. So anyway, it's just very simple plugins system, which is not loading plugin externally yet, which is just so that means I'm just playing around with in the main source base. So what you can do is create a new plugin. A plugin has to, be the derivative of the emulator plugin, which is having some very basic. Let me put this a bit more. Sorry. Oh, like this. Which is just having very simple events like key down, key up, mouse down. And you can get the debug interface. The debug interface is a kind of generic class which has generic methods for all the emulators. So now we have the Commodore 64 Vice 3.1. We have the Atari 800 open source emulator with my changes, and there is a very so it's here. It's very basic version of the NES, and which is working. I can run, some nice Contra games, whatever. So what the plugin actually has this API. Yeah. So API is a debugger API, and it's this particular debugger API, as I said, is not finished yet because it's focused. It's gonna be in the future. It's gonna be just the Commodore 64 Debugger API, but in principle, so it's not for other platforms yet. But what you can do here is do some basic things like create new picture, start new thread, for example, if you wish. So you can start whatever, how many threads you want, your own threads. Switch to Vic editor, clear reference image, load reference image from PNG file. Set layer visible, get reference image from the Vic editor. Set the top bars, toolbars visible, zoom display, clear screen, convert image to screen, meaning that you can load PNG and it will try to convert to the current display mode. And get screen image, which is quite important feature, or get screen image without borders, because it's giving you the image data, this is class like regular class with some get pixel, set pixel, which gives you the RGB screen in real time. So if you have, let's say, some would like to do some calibration, see where pixels are on the screen, you can do this, right? Or what you can do also is change this picture and put back to the. It's for prototyping effects, I would say. So it's not rather just for implementing, right? Like we would like. This is something which I told you at the beginning. So my aim was to create some tool for me where I can, prototype my effect in C, check all the equations if they are working, and then I can go to the assembly, right? Find color from RGB, paint pixel, paint reference, set byte to RAM, get byte from RAM, detach, clear RAM, assembly. So you can assemble here. So that meaning that you can just put assemble at address, that address, say LDA, something like that. Adding watches, prepare basic upstart, so meaning that it will put the sys whatever. Load PRG, load SID, and will give you where it was the init address, the play address. Save exomizer PRG from memory, that meaning that it will compress and save. So I'm adding to this debugger the exomizer, so it's of course external. Save PRG, save just binary, and sleep. So you can just sleep if you have a thread, for example, 1000 milliseconds, and do something. And here what we have, of course, our thread. So what I'm doing, this is a plugin dummy, some example plugin. What I'm doing here is switching to a weak editor, starting thread, which is this, just this. Thread run is a method where you just put your thread. This is some pull of the just char buffers. So you can just take from my engine just the char buffer, which is very long enough to play with. Clear RAM. I'm here assembling. So I start my code at 0f00. I do some inc d020. I load seed. I create new picture, sleep, clear screen, and okay. So next, very important is the do frame. This do frame is being run by my engine whenever we hit the sync, file sync. So it means that we should here have the fully, painted picture on the screen. So Vic flashed everything, so we are on this lowest raster line. So you can get, of course, the image from using this get screen data whatever method. And you can, I just put here some, fun stuff, like I just paint some pixels from this value to that value, and I'm changing this colors here. This is static value, so every frame I'm adding some, so do some changes, right? And in this for loop, I'm painting pixels. So this is exactly this for prototyping. So you can prototype here your effects in C, put in the running Commodore 64 your, if pixels results from calculations, pause emulation, start emulation, and check the results if they look good. And you have key down, like for example, arrow up, key down, space bar. So if I hit space bar, I will save the exomizer PRG. So you can run this on a real hardware, right? Assembly. Okay, so of course, here you can see some defines I just added to be much easier. So instead of, having this assembly, put buffer, whatever, you can just use this, meaning that I just print this to the buffer and use the arguments, like for example here, right? So I just jumped here. Let me start it. This is compiling the whole debuggers. As I said, the plugins are not are now in the main source code. So I'm going, of course, to remove them and from the base, but I need to finish this first. So it's like good for prototyping. In Linux, it's very simple. You just put make, enter, and it compiles it for you. And on the on the Mac OS, you can just use Xcode. On Windows, it's a bit more complicated. So you see, this is my nice effect for like my prototype effect from this code. Okay. Alrighty. So the end. As I said, I'm gonna put the Star Wars demo, and once again, this time for sure, thank you very much.